Alright, today we're going to be looking at solving by elimination continued. Alright, so let's get into it. Remember, our first method is graphing, our new method is elimination. If you recall, most of the time that we did elimination before, we had all of our x's and our y's nice and lined up. This time we don't. So what we're going to do is work on lining everything up. Remember, most of the time it was ax plus by equals c. Kind of like this one. Here's our x and our y are equals and our c. So this guy's good. This guy, however, isn't quite there. We need some work. So what we need to do is we need to get our x's and our y's on the left side and our numbers on the right side. So the first thing I'm going to do is I'm going to move this x over by subtracting 3/4 x. Now these guys don't combine at all, so it's just negative 3/4 x plus y equals negative 5. Now, it's not convenient to have that fraction there, so if you want to keep it there, you're okay. I'm going to go ahead and get rid of that fraction, and I get rid of the fraction by multiplying everything by 4. So when I do 4 times negative 3/4, I get a negative 3x plus 4y equals negative 20. And remember, people most often forget to multiply this guy. Alright, now we get that one. And now I'm going to take this guy, I'm going to bring him down as well. So I've got a 5x plus 2y equals 16. So I just took this one and brought it down. Now if I add these the way they are, it's not going to do me any good. The key is, what could I make these guys look like? I can make them both look like 15, or I could try to turn both of these into a 4. It's easier to turn these into the 4. It doesn't matter how you do it, but that's what I'm going to do. So I'm going to multiply this guy. I'm not going to multiply him by 2. Since this is a positive 4, I want this to be a negative 4. So I'm going to multiply by a negative 2. So this guy carries over. And then this guy, since I multiplied everything by 2, 10x negative 10x minus 4y equals negative 32. Alright, so now I'm going to go ahead and add the two equations now. This gives me negative 13x, 0y, negative 52, divide by negative 13. And you're going to get a positive 4. Alright. So now we have our x value. So now all I have to do to find my y value is to plug it into any equation that has an x and y. I can plug it into this one, this one, this one, this one. Doesn't really matter which one or any of these. Personally, this one's the easiest, because it's already y equals. So I'm going to y equals 3/4 times 4, because x was 4, minus 5. And if you type that in your calculator, you get negative 2. And all you got to do is just do 3/4 times 4 minus 5 in one straight line. So here's what we're saying. We're saying that this line and this line intersect at the point 4, negative 2. And that's our point of intersection. Alright, if we graphed them, that's where they would cross. But we always want to check our answers. Since I plugged our x into this one, I'm going to plug our answer into the first one. So I'm going to come down here, 5 times x plus 2 times y equals 16. That's 20 minus 4. That does equal 16. So I feel really good about my answer. trying to eliminate as many little mistakes as we can by checking. It's easy to make a negative sign error or to add wrong or something like that. So this kind of helps us make sure that we don't make those type of mistakes very often. Alright, now we've got this one. This guy's all kind of weird. Remember, we want x and y on the left and our number on the right. So our variable's on the left and our number on the right. Well, when I look at this guy, I'm going to take a look at the x is on the left, so that's good. But the y is on the right, so how do I get rid of him, or how do I move him over? I have to subtract 7y from both sides. So this is now 3x minus 7y equals 5. So now I look at this one. This y is in the right place. This x is not in the right place. Okay. Some of you guys might realize that this is in a good place, but this is not right. I don't want a plus y on the right, so I gotta move him to the left. Minus y. You can do this in 2 steps if you need. But here, the 5x isn't going to combine with anything. 10y minus y is 9y. And then this cancels and this cancels, and I'm left with 5. So I have negative 5x plus 9y equals 5. Alright. Now I'm looking at this, and again I have options. I'm looking at what can I turn these guys into. I can turn them both into a 15. These guys might be a little bit harder. It might even be a 63. So let's turn these two guys into a 15 and a negative 15. Luckily, there's already one positive, one negative. So we're going to make this a positive 15 and multiply it by 5. And we're going to multiply this by a 3 to get negative 15. If you're ever not sure what to multiply by, start by just switching the numbers. You don't have to necessarily move the sign with it. Just try to keep one positive and one negative. But start with just switching the numbers, and that'll often give you a good starting place. So this is 15x minus 35y equals 25. 15x plus 27y equals 15. And then we want to add these two. 0x minus 8y equals 40. And then we get y equals negative 5. So now we have to find our x value. To find our x value, we are going to plug this in to any of these equations that have x or y. It doesn't really matter which one you plug it into. Okay? I'm going to plug it into this guy right here. So I've got 3x equals 5 plus 7 times negative 5. This you can just kind of type into your calculator. 5 plus 7 times negative 5. And you get negative 30. Divide everything by 3. Get x equals negative 10. So I'm saying that this line and this line are going to intersect at the point negative 10, negative 5. But I always want to make sure that I got the right answer, so I'm going to check it. I'm going to check it with this equation since I already used this one. So I'm going to use this guy right here. I'm going to do the work down here. 10 times negative 5, that's my y. 5x plus 5 plus the negative 5, because y was negative 5. This side is negative 50. If I just type all of this into my calculator, 5 times negative 10 plus 5 plus negative 5, I get negative 50. So I feel good about my answer again. And there we go. The big key here is that we're trying to get them into the x and then the y and then the equals and then the number. That's the only new step. All this multiplying business is a repeat. The only new step is doing what we did in the blue here, where we had to rearrange the terms. Alright, last one before a word problem. Neither of these are in standard form, right? We're trying to get x and y on the left and the number on the right. This guy does not fit that description. Y is on the left, but x is not. So I've got to add x. So I'm going to get a new equation. X plus y equals 16. Then I come over here, and there's a lot of fractions. If you don't like these fractions, the first thing you can do is multiply by the denominator. You multiply this by the denominator. What is the denominator? It's 3. So I'm going to multiply everything by 3. And if I do that, I get 3y equals negative 2/3 times 3 is negative 2x plus 38 thirds times 3 is 38. So that's not nearly as bad as it once was. Keep that in mind. Whenever you have fractions, you can just multiply by the denominator. But again, I've got y's on the left. That's good. X is on the right. That's not where I want it to be. So I'm going to move these x's over. So I've got 2x plus 3y equals 38. I'm going to kind of move these over here. You can do anything you want with these guys. Again, the goal is we need to turn these into the same number, or I need to turn these into the same number. They're equally easy. It's just one multiplication. So I think what I'm going to do is, if this is a positive 2, I'm going to turn this guy into a negative 2. So negative 2x minus 2y is negative 32. 2x plus 3y equals 38. Let's add these. Remember, if nothing eliminates, it's not a good idea. Those do eliminate. That's just a 1y equals 6. Oh, that's pretty easy. It's a 1y. I don't have to do anything else. But to find my x, I got to do something with this. Plug in any equation you want. This one, this one, this one, any of these two. I'm going to plug it into this guy right here. So I've got 6 equals negative x plus 16. I'm going to subtract 16. Negative 10 equals negative x. Divide by a negative 1 if you need to. And I get 10 equals x. So I'm claiming right now that 10 comma 6 is my point of intersection. If I were to graph the two lines, this is where they would cross. But I always want to check it before I circle my answer. So we're going to check it using the second equation that we haven't used yet. Y is 6 equals negative 2/3 times our x plus 38 thirds. And again, this is just a calculator work here. Type in negative 2/3 times 10 plus 38 thirds, and I got 6. And that's a good statement. 6 does equal 6. So again, we feel really good about our answer. It's all about rearranging. Okay, keep that up. Just keep that in mind. You have to get the x's and y's on the left and the constant on the right. Okay, I got a word problem. I'm not going to actually solve this one. We're just going to kind of set it up, and then we'll kind of leave it there. A school needs to buy a total of 450 cap and gowns and tassels for graduation. They need to order twice as many tassels as cap and gowns. How many cap and gowns and how many tassels do you need to buy? I said this last time, but the last sentence a lot of times tells us what our variables are. How many cap and gowns, how many tassels, those have to be our variables. So we'll let And we can use any variable we want. We can use x and y, we can use c and t, doesn't really matter. We'll let this be c for cap and gowns, and we'll let t be how many tassels we have. Alright, so I'm telling you what my variables are. C is how many cap and gowns. T is how many tassels I need. Now read the first statement. A total needs to buy a total of 450. Well, that just means that when I add the cap and gowns to the total number of tassels, that should make a total of 450. What's this guy right here? The next sentence gives us a clue. They need to order twice as many tassels as cap and gowns. Twice as many tassels as cap and gowns. Well, that means you're not ordering the same amount. I'm not saying that tassels is equal to the number of cap and gowns. I'm saying that the tassels are more. How much more? Twice as many. So I have to double the small number to get the number of tassels. If you double the cap and gowns, you get the number of tassels. So now I've set it up. I can ignore the word problems now. That's the first step. Define your variables. Look for two equations. Okay, I found two equations. If I'm solving this, my first step is to get everything lined up. Right? Remember, we want x and y on the left. Well, in this case, it's not x and y, it's c and t. Well, if I draw my line here, c and t are on the left, numbers on the right. Here, t's on the left, good, but c's on the right. So I'm going to get rid of that and move it over here. And so my new equation is a little simple. Negative 2c plus t equals, what's over here? 0. You have to write a number there, you can't just leave it blank. C plus t, I'm just copying this guy over. Alright. If I were to do this, I have options. I could turn this into a positive 2 by multiplying by 2, or I could turn this into a negative 1 by multiplying by negative 1. So if I wanted to say, you know what, let's multiply this by 2, I would get 2c plus 2t equals 0. Oh no, my mistake, hopefully you caught it. This number is supposed to be 450. So 2 times 450 is 900. Negative 2c plus t equals 0. Now you can add these two guys and you can work the problem out from there. Okay, I'm not going to do it right now, I just wanted to focus on the setting it up type of part. Alright, you try. I'm going to go ahead and pause the video, work it out. If you get it right, great. If you don't get it right, you can look at my steps and see if you did anything differently. So go ahead and pause the video now. Alright, here's the answer. You might have thought you did it wrong because how big the numbers were, but it is right because I checked it. But it answers 30,123. This would have been a bear to graph because the numbers were so big, so I'm glad we had some other method besides graphing. If you got this right, go ahead and skip to the next slide. If you did not get it right, go ahead and stick around, I'll try to explain it. So here, we've got, I've got to move this to the left, because I remember I always have to have x's on the left side, right? So I subtract 4x from both sides. Over here, I didn't like the negative 2/3, so I just went ahead and multiplied everything by 3 just right off the bat, because the denominator is 3. 3y, negative 2x, 429, just multiply each of these by 3 in my calculator. But then, even though I got my y on the left, I still need an x on the left, so I add the 2x. With the answer here, 2x plus 3y equals 429. Again, I had two equally efficient options here. This is a negative 4, so I can turn this to a positive 4. This is a 3, I could turn this into a negative 3. I chose to go this route, but it doesn't really matter. Multiplied everything by 2. Added to get 7y equals 861, divided by 7, got my answer. Took this, plugged it in over here, did the work right here, so hopefully you can follow that. I get x equals 30. And I was a little concerned, my numbers are kind of big. It's possible they could intersect there, but I went ahead and checked it, so I took my x and my y and I plugged it into the other equation, this one here. Did the work over here, so y equals negative 2/3 x plus 143. Just typed this into my calculator, didn't do any work in my head, got the answer, or got that as a true statement, so I knew my answer was correct. Alright, got a summary page for you. What are two methods? You know how to solve a system. What is necessary to do before using the elimination method? This is an important step. In step 3, what would be your first step in solving? There's not one right answer here. I'm just looking for what is the first thing you would do if you were going to solve this by elimination. Go ahead and write down your answers somewhere and we'll talk about them in class.